All right, welcome everyone to the HashiCorp Ambassador Thought Leader Series. We've got our best community members and experts on here talking to us about all the big ideas across infrastructure and security, the entire life cycle, and the whole knowledge base, really. That's all of the different categories. If you're in our community, you know the different products, hopefully. If not, then just keep watching more episodes, checking our stuff out, and you'll get to know them. But we've got some techniques, principles, and lessons that we always want to teach you. And today, obviously I've got another, as usual, a guest. I feel like I always do this in every episode. I'm like, oh, he's over here. I wonder who he is. But there is a name tag, so you would know. But before we get into that, as usual, I must tell everyone, we want you to participate. We want you to ask questions. We will try to get to them, but please be nice, right? Be good. Spread the goodness for the sake of our guest here and really just for me. And if you're confused as to what that means, please check out our community guideline link here so that you can figure out what that is. And just to answer a question that does get asked many times, this is being recorded. So if you have to tune out early or whatever, this will be on YouTube after the fact. However, we've spent enough time on this. Let's go ahead and get into our guest introduction. Who do we have on screen here, if you will?
Well, Cole, thank you so much for having me. My name is Michael Aldridge. I am an engineer at a company called Backblaze. We're the people with all the hard drives who post on Reddit about what we found that works and doesn't work. I'm one of the people who keeps our physical data centers running and does a lot of automation tooling to try to make things a little easier on engineers who may get woken up in the middle of the night.
Oh, you're doing the good work, right? To save a lot of people. And not only that, every time I talk to Michael, first up, I have a quick story about Michael. We were at HashiCorp this past year, and we had a HashiCorp ambassador panel, and last minute, one of our guests had to drop out. The day of, I go, Michael, hey, I know it's short notice, man, but can you step in and be live for us all of the internet? Michael was like, yes. He stepped up and he did absolutely wonderful. And after that, I was like, I'm going to milk this person for all the knowledge that he has. We're going to put him everywhere. And here we are. However, every time I talk to him, he has a ton of wonderful ideas. And today, the idea that he brought when I got together blew my mind. It was such a neat concept. And Michael, could you tell us about it?
Yeah, so while the cloud is a wonderful place, I've spent the bulk of my career working in physical infrastructure because the cloud is just someone else's computer. And one of the really cool things that I've been working on in the last couple of years has been looking at, Terraform is a great infrastructure as code tool. And if we can terraform the cloud, well, why can't we terraform the physical stuff too? And the place I kind of started working on that with was terraforming the physical network so that we can treat our actual network made out of cables and routers and switches like its cloud counterparts.
And that was the name of the episode that he came up with as the title. We saw that he wanted to talk about pizza some, but we were like, that's probably a community inside joke. But this was a really neat idea, right? Because when we talk about Terraform, we tend to automatically go to cloud. At best, some of the different other software as a service out there have an open API that we've written providers for. But I was like, oh, you mean like a cloud network? He's like, no, Cole, like a real network, like actual. I was like, oh, okay. You got to tell me about this because immediately there's some stuff that we have to address, right? Which is like, well, hold up. Don't I need an API to interact with something as Terraform? And how am I doing that in a data center? We're going to get into kind of some of that. Like we're going to answer some of those questions once we dig into it. But in terms of what we're going to cover in a nutshell, that was the main idea, but what kind of walk us through the flow of how you'd like to talk about this today, Michael?
Yeah, so I think we're going to kind of hit a couple of really big ideas here. We're first going to jump through the terminology and the context, especially for people who may not have, eat, sleep, breathe physical hardware. That is a world fewer people work in. So we'll want to cover the ground there. We'll kind of look at when we talk about the network, that's like a really big thing. And we're going to have to break that into smaller pieces to be able to work on. And how would you approach that kind of a problem? And then kind of the last one we'll touch on is, Terraform is a tool that does things automatically. And when we go from doing things by hand to automation, there are some safety concerns we've got to get into and address.
Ah, yes, good old risks. But there's no fun if there's no risk, right?
Oh, risk is what makes it exciting.
Yeah, exactly. So here's the thing. When we were talking about this, we went down this rabbit hole. We had a lot of fun, and then I popped up. And I said, okay, we do need to bring something up here, which is a lot of our audience has been very cloud native, or they've been on-prem trying to become cloud native. But either way, most interactions have probably been in that space. So the question that I have for you, Michael, is like, if you aren't in the physical infrastructure space, why is this important? Why should you learn about this and pay attention? What are you going to get away from it?
Right. So I think there's really two reasons you'd want to care about this. The first is that Terraform is a fantastic tool for enforcing process, and processes are perhaps the single most powerful tool in engineering to build something and get it out the door. However, if you have too many processes, the problem starts to become recursive. And so if we can figure out some way to deal with all of our infrastructure using these same processes we run our clouds through, then it's a lot lower cognitive load on people. It's a lot easier for people to reason about. And it's a lot easier to just keep a lid on the number of things you've got to do in a day to get a change through. The second reason to kind of care about this is that you may be a fully cloud-based company, but you probably still have a corporate office. And that corporate office probably still has Wi-Fi in it. So somewhere you have a network, and it is physical. And even if you don't, the concepts are still portable. When we talk about things like architectural modeling, it's useful to learn about things that aren't your core skill set because they make you a better engineer overall.
That's a very, very good point. And when we were going through this, it was interesting to see if you're unfamiliar with the concept of providers, if you're unfamiliar with the concept of Terraform, this will level you up in that area as well, because it's going to force us here to discuss some of those deep technical fundamentals that you'll need to understand that will have to be in place if you are going to make it and step into Michael Aldridge's world where we can terraform everything, right? All right, awesome. So treating your hardware networks, right? With just like the cloud with Terraform here. This is important because, it's going to teach you a lot. You're going to encounter this. You're working with physical infrastructure, whether you know it or you know it. We have three big sub ideas, right? We're going to begin with some context. We're going to step into the modeling of things. We're going to go into the risks there at the end. So why don't we get into this first subtopic, this first idea, that terminology and context, Michael. So kind of give us upfront what we're going to cover here, if you can.
Sure. So we're going to talk about actual bare metal. And let's go ahead and make that really concrete. When we're talking about bare metal networks, we're talking about things you can hold in your hand. Physical routers, physical switches, cables that turn into spaghetti. The way I've described this to some people before is if it's hardware that you can retire by throwing it off the roof, that's the bare metal component of the network. And I've yet to find a rage room that will let me bring in old routers. But that's kind of the gist here. Is this is physical stuff. It's at some point, your connection from your laptop all the way out to a data center, it goes over physical cables, and that's what we're talking about today. We're talking about these real concrete components that are underneath the virtualized networks that we all enjoy in the cloud.
Yeah. So give me to set some context and definitions and terminology for the folks who haven't stepped foot in an actual data center. We have what they probably know, the Terraform code, right? We have it keeping track of state under the hood, reaching out to a provider that translates that code to API calls out to what they normally know as just the cloud. All right. This is changing in your talk. This is reaching out to what, right? This is where we started digging first. It's like, well, what is it reaching out to? Like how is it interacting with the components in this data center? Let's kind of start from that where people know, and then we'll kind of dig into some of the other stuff if that's okay with you.
Sure. So at the most concrete level, let's talk about what physically is it talking to. These are rack mount devices. They're usually between 1U for the more modern, very moderate things, all the way up to, I started my career working on Cisco equipment where the single unit was 42U tall, occupied an entire cabinet on its own for one device. These are, actual physical devices. Most of the times you would interact with these by SSHing to them. Or if you're in the physical data center, you might plug a console cable in, and you might connect to it using a serial terminal. These are very much line-oriented interfaces. They're very command line based. You you key in what you want it to do, and then because networks are sometimes fickle creatures, a lot of times these have a concept of queuing up changes, and then in one go we commit those changes and make them active. Now, when we talk about Terraform, you bring up the concept of a provider, and I think if we look at the statistics in the Terraform registry, probably greater than 99% of all providers talk to an HTTP-based API. But they don't have to. A provider is just some code that Terraform uses to translate between a resource and a thing that needs to know that resource. So on some network equipment, this provider might actually be opening an SSH connection to that equipment and driving the CLI. That is kind of the, you could make that work with anything approach. But, and this is where the world is changing, a lot of the large network vendors now provide APIs for their equipment. Junos has the netconf system, and that's an HTTP-based API. And Arista has their own APIs that are gRPC-based. So these are very modern technologies that we're starting to look at and see all the way down in this network hardware. So you can do it still with SSH, but you can also now start to connect to these using these hyper-modern RPC frameworks.
So let me summarize here for my own understanding and the audience's.
Of course.
In 2025, right, and probably a bit back, these modern 1U machines that we've got out there in the physical data centers, they are finally coming with the ability to interact with them via API. Now, that wasn't strictly necessary to work through a provider, but that's obviously going to make things a lot easier. And it's obviously going to translate a lot easier if you're already familiar with interacting with an API, right? So if you've been writing providers for other things now, you have that the network hardware out, or the hardware out there, and you can write some provider code to interact and go with them. And that is Michael's current approach. Like if I were to drop you in a project, say, hey, I need to automate my data center with this, and you get to buy the hardware, you get to set it all up. This is the approach that you're going to take.
Right, and I think that is an important consideration you just raised there. This is, like many projects, much easier to do greenfield. If you get to say, well, we're building a new site, and we want to do it with Terraform. Well, obviously, you're going to pick the easiest path here, which is looking at hardware that has high-quality Terraform providers. We can write this code, it's no problem, but it's a lot easier if somebody wrote it first.
Yeah, that is fair. However, if I were to drop you into a brownfield situation where it was a mix of new and old hardware, we know what you're gonna do for the new hardware, but for the older hardware, you're gonna write a provider that does not interact over the HTTP protocol. It's instead you're probably gonna have to write it so it does what you originally talked about, which was SSH, right?
Right. Or if we're talking about some really old hardware, we may even be talking about Telnet to it.
Okay. Wow. Okay. Yeah.
So
when we're looking at that as the different ways, let's just go ahead and for all that, it is possible, regardless pretty much of where you are in your hardware stack. I'm assuming if you go back too far, we're probably going to encounter some issues, right? However, or no?
Well, so yes and no.
Okay.
The fun thing about engineering is that you can create the problems that you then solve later. And if you go far enough back, we're talking about, in one of my fun side projects at the moment, in a hobby of collecting telephone equipment. Oh. Yeah, a lot of that equipment predates IP, but a provider is just code. There's nothing that stops us from teaching Terraform how to pick up a phone and dial a modem. And once you have any means of communication back to the device you want to configure, now it's just details. Once you can hit the configuration interface for a device, Terraform can manage it.
So I think this really comes down to, and this is something that I've tried to I don't know if harp's the right word, but I have been, of everything is code, right? Because, and even though infrastructure does encapsulate it, that's generally us trying to make things easier on the people consuming the message. But the reality is you can go full Michael Aldridge on things, since now you're a verb. And you can,
I see.
Yeah, and you can do that. So let's address the next question. We've got that magic. Oh, wow, all right. So now I can manage and do the whole life cycle of physical hardware with Terraform. Someone's gonna ask a question, but Like, how does that hardware get set up? Like, I know that in the cloud, I can say, give me 3 more, VMs. But in a physical net, data center, what has to happen for me to scale out the literal hardware? Are you telling me that I can write Terraform and a magic entity will just appear, hook it up, and like I'm missing something? Like technology's advanced that far? Like how do you manage the actual physical side? I assume there's some sort of setup at the get-go, right?
Right, there is some sort of setup there, and it's funny you talk about the magic scale out there, because when I was working for Google, I can remember a point in time where I learned we had APIs that would dispatch people with shovels to go dig up the fiber. It's like, yeah, you write an API for it. Go make a Jira Terraform provider.
Oh, that's good.
But this is where you're right. It's physical hardware. So I have to give a huge shout out to the amazing people who work in data centers every day and are those people who do that scale out. For me, if I need to provision a new device, usually this will start with, always it starts with the question of what are we going to do with that device? Because provisioning hardware for hardware's sake is not healthy. So we say, what do we need? We decide the device, because these are not elastically scalable. You get what's in the metal box. And if you say, I need 128 gigs of RAM, well, some human is going to go put 128 gigs of RAM in a box. That's what you get. So once you have that, then you cut a ticket. It's Jira, or it's Service Desk, or it's OS Ticket, one of these various systems that you work with the people on the floor. They'll go physically pick up a device, bolt it into a rack, plug the cables in, and then depending on the capability of the hardware, now you get to approach how you're going to bootstrap it. And there's various ways you can approach that.
Yeah. So let's pause on the bootstrapping thing and let's go back here. So for our folks who are unfamiliar with this, one of these first conditions is your actual physical on-prem hardware needs to be set up. It needs to be configured. It needs to be ready to go. Any net new devices you're going to add, you still have to have someone go there, plug them in, get them integrated and join the rest of the system first before you can start managing them, correct?
They have to at least be physically racked and powered on.
Okay.
It really depends on the capabilities of the device for what its power on capabilities are going to be. If we think back to the early days of remote hands and remote management on Linux servers, it kind of ran the gamut. You had stuff that it would boot up, it would find a magic DNS name, and then it could go pull down config, and it would look like it had always been there. It had zero-com. But then you also had stuff where it was like, okay, I'm going to get on the phone with somebody on the floor, and they're going to wheel a monitor over on a crash cart, and I'm going to walk them through how to set this thing up the very first time. And it really still is that spread. There's that breadth of, when you take the hardware out of the box, depending on who made it and also what you licensed it for, it will have different capability.
Gotcha. So when it comes to the actual physical side of things, right, we cannot discount, as you said, as you gave the shout out, the actual people on the data center floor that will, both in the beginning and every so often, need to actually do some of the configuration on the floor itself, right? And when it comes to, so if I trace back to this original point of the API call from the provider coming into the data center, that hits what? Each individual machine, or is there some sort of controller that it hits that then fields the request out to the rest of the hardware that's there, right? Because you're saying it needs to at least be racked and powered on, and assume it also needs to be reachable from whatever controller or ultimately, I guess, your provider in order to configure it and manage it, right?
Absolutely, and it really depends on the vendor. To give two examples, so something like a Ubiquity Networks platform, where they are very controller based. They have an SDN capability that comes off of that controller. That's what your provider is talking to, and then that controller will then go make the API calls out to the rest of the devices under its purview. And this gives you an ability to say, in that case, you really only need that controller up and active, because that's what you're talking to. For the big iron, for things that are doing 100 gigabit line rate across 20 or 30 ports, those tend to be a bit more, I don't want to use the word isolated, but more individually contacted.
Okay.
These are devices that, to use the RFC word, they shall not go down. And
Yeah. Okay.
when we talk about things that shall not, bolting a higher order control plane onto that can represent a risk we're not willing to accept.
That's
So
fair.
it's a lot easier and a lot safer to have Terraform talk directly to each device.
Okay, yeah, that makes sense. And so before we go into the next part, I think you had one takeaway here, and the third one you want to do, because that kind of bridges into like a question that the Terraform nerds are going to ask next, right? Like myself, which is like, wait, well, hold up. Does this mean I've got like one workspace per big iron device or one per Ubiquiti? Like but I think that's kind of in your next thing. But
Right.
what else do we need to know in this section of terminology and context before we move on?
Well, I think the last really big point I want to hit for context is that, this is a lot of work. So what do you get for it? And to me, one of the biggest, I cannot, understate the value of it is Terraform gives you a diff. And when we talk about the physical network and when we talk about things like this, if you're in a publicly traded company or you work in a regulated industry, you deal with audit and compliance. And they are always wanting to know, what did you change? Who changed it? Can you prove why it was changed? This is really easy to do in the cloud. In the cloud, we get things like AWS CloudTrail, or we get things that tell us, who touched what when. When we get, sorry, I have a phone ringing in the background. We get to the physical network, though. This is a lot harder. Your auditors are going to ask for things like, show me your door access logs. Who physically was there? And that's pretty easy. Your doors are usually logging that. What becomes a lot harder is when they say, okay, this ticket that I see in this system that said, provision this port on this device. Show me what you changed. That's a hard question to answer, because usually that involves needing a lot of logging infrastructure. You may be wading back through, let's say OpenSearch data. And it's not going to be in a format that somebody who's not an engineer can readily understand. And I think that's something that Terraform does extremely well, is it condenses any change just down to what actually changed.
Gotcha. So that brings sort of that, the concept of that system of record now to the physical world, well, the physical infrastructure, which is huge. I have a kind of a quick aside on that, right? Because you mentioned this at the beginning. You're like, it was surprising to me when I figured out there was an API for, giving tickets, get people go out with a shovel, right? Is that in Michael Aldridge's like world of ideal physical infrastructure data center management something that you would also include, where you can run a Terraform apply and have your data center person go up and hook up the new device? Yes? No?
So I'm kind of torn on that. In one case, I absolutely despise anytime I have to open up the ticketing system. Because I've yet to find a ticketing system that I really jive with and that I like the interface on. I live in the CLI. And so if I have to go fire up Chrome and load the ticketing system and figure out, which project do I need to file under, that breaks the flow state I might be in.
That's a good point.
But on the other hand, and this is something that I have seen happen in the last couple of years, the more we abstract, the easier it is to lose your understanding of how things work.
I like that. I like that a lot.
Absolutely. And so it's like, I file the ticket for record because we have to have the ticket for any work that was done. But I'm still going to reach out to the real live human who's going to do that work, because they may know something from having boots on the ground that I don't.
Oh, okay.
And, they may give me some information that says like, hey, are you aware that we're going to do maintenance in that area next week? And, you're asking a whole lot of fiber to be run to a switch we're planning to turn the power off on briefly.
Yeah.
They have that knowledge that you can't get via API easily.
Yeah. Or you can make their life absolutely miserable and make them all do it through the most inconvenient.
No.
No, yeah, because they're keeping you up and floating. So I think that moves us in to the next point, and before you name sort of the idea of what you want to do here, I want to just preface it with like the curiosity of, okay, we've gotten past the terminology. We are looking now at a data center where we'll go mix greenfield, brownfield, to where now Michael knows that if he writes his provider, right, and interacts with the different machines appropriately, some with an overhead overall controller that controls some machines behind it, some directly you have to go to. The next question becomes, how the hell do I manage all this? How do I start writing the code? How do I start thinking about the projects, right? And that kind of brought us to what, like, can you tell us what that second idea was that we're going to dive into?
Yeah, so I think that while the cloud and its fluidity and in compute and platforms like Kubernetes have really allowed us to sidestep a lot of architectural modeling because we can make the underlying resources elastic, the network isn't. You provision there and you have a certain amount of headroom, you have a certain amount of, I'll use the term protected bandwidth, that's your N+1, but that's all you get. And so you have to plan it out. And the way that you manage this is the same way. The way you architect your Terraform workspace matters. So doing that architectural modeling, especially in a brownfield project, where, in my opinion, the brownfield projects are actually the ones where this kind of workflow has the most value, because it allows you to abstract over perhaps that, the new hardware you just got, the old hardware that you've got to keep the lights on with it because it was very expensive and it's still doing a job. And then that one absolutely ancient device over in the corner that you can't get rid of. This layer of abstraction, a brownfield project, is very powerful, but you have to model everything in a way that's useful to be able to actually get that value back out.
Okay, gotcha. So just so that we can give people like sort of a concrete story to start hinging, going with. Just give me an arbitrary number of devices you're managing and a sized network. And then what do the Terraform workspaces look like, right? Like what is each one in your head just initially? Let's just start with the easier one, like ones that like a Ubiquity one where there is one controller managing many devices behind it. What do these workspaces managing that look like to you? Like what resources are in them?
The Ubiquity one's a great example because that's a corporate network, and everybody's got a corporate network somewhere. Even if it is, you work from home and you set up a second SSID for your work laptop to join, that's still a corporate network. In that case, I usually find that I've got a workspace that has one provider in it. It'll be talking to that controller. I may have. Depending on how I'm going to actually orchestrate this workspace, I may be running this in CI. I might also pull in like the Vault provider so that I can dynamically pluck out the API keys. Nice. I'm definitely not committing a secret to Git.
Yeah.
We always want to, dot the I's, cross the T's for security. And then we're looking at, resources that are broadly anything you can click on in a UI or an element you can configure in a CLI is broadly going to be one resource.
I like that. Okay.
So in the case of like a Ubiquity wireless system, configuring an SSID, that's a resource. We're going to have a resource that'll be like Ubiquity SSID, and it'll take the name, it'll take the channels, it'll take perhaps a security config for if we're doing like a pre-shared key, and it'll fully encapsulate that SSID.
Okay, nice. That's a very wonderful and very digestible way to think about that, right? If you can click on it, that's probably a resource, right? And then suddenly thinking about it is a lot like how you see some folks teach Terraform from the AWS side. They're like, look, use the UI as a visual for what's happening, right? You're literally clicking in, making an instance, selecting attributes for it. Well, in Terraform, this resource is a representation of that work. You're saying, do the same thing with this particular flow, one's with those controllers, something with the UI, right? Cool.
Yeah, and then I've seen some providers as well, and I love when people do this in the documentation when they're doing things that have a CLI. The resource name will match the CLI path to get to it.
Oh, that's nice.
So it's like, I want to manage like interface link mode. So the resource will be provider _interface _link _mode.
That's actually very digestible. It gives you a lot of information And it kind of almost generalizes the interface into the interaction, as opposed to there being a different way to speak about it, whether you're in code, CLI, UI, like. Okay.
Right, right. It just makes it more approachable.
It does. And it lets you use knowledge that you have from other interfaces to reinforce the new one. So that's that model. But now let's drop Michael Aldridge into a case where we have the big iron, right? The older machines, the ones that, as you said, are a little bit more individualized. Let's begin with just one, right? Just one of these machines. What does it look like in this world now in terms of providers, workspaces, and everything there?
Yeah, so in that case, you're still going to have I'll still pull in my Vault provider to get my tokens so that I'm getting my secure access, and then I'll have a provider per physical device I'm talking to.
Interesting.
Because one of the input parameters for that provider will be the address of the device it's managing.
Ah, okay.
So it'll need to know, okay, what am I connecting to, what port? If you're using an internal TLS chain, you'll usually need to feed it the CA cert.
Okay.
So that it can validate that connection. And then the workspace, usually you'll want to carve it up based on, I use the term like on a functional block diagram. Where is the thicker border? And that thicker border can sometimes be a geographic one. It can be, this workspace is only going to touch, hardware in, let's say, the U.S. Central region. We probably don't want to be having a Terraform apply touch things on multiple continents. That's a great way to break things.
Yeah.
But then it's also carved up on authority. We might say that, okay, our internal routing equipment and our internal switchgear, we're going to let the broad population of operations people touch those. Because we're constantly reconfiguring those, recycling hardware, we're building and changing. So we need more people to touch those.
Yep.
But maybe our internet-facing routing equipment, the stuff that if we break that, and you see this happen about once a year, somebody at a company will have an oops moment, and the internet as a whole bumps.
Yeah.
And it's like, yeah, maybe you restrict the set of people who can touch that on the edge, and it goes through more strict reviews, more scrutiny. Well, that you then need to put into its own workspace so that an apply that's going to touch that doesn't have to touch everything else. And vice versa, an apply that's only touching a port on the internal network doesn't have to wait for an approver in this other workspace.
Okay. So let me clarify some things with you here, just so I understand it. First up, each of these older or more individualized machines, or maybe not, maybe it's brand new, but it's still individualized, right? Regardless, that's going to require its own provider, right? Because, if you get that same machine, sure, one provider will cover all of them. But the reality in a brownfield, you're probably going to have a lot of different ones. Each of those is going to require its own provider. So here's my first clarification question. In one workspace, let's say that those are all meant for the same functionality, they just happen to be different versions, different types, right? In one workspace, would you then have, let's say, the 10 different providers for each of the 10 different machines in this one workspace, managing them each? Assuming they're in the one region and they're in one geographic.
I see what you're saying. I want to clarify something there.
Yeah.
And we're opening multiple instances usually of one provider.
Okay.
So when we talk about network equipment, the network engineers are going to hate me for this. These are just servers with multiple network cards.
Yep.
There are still in places the hyper-specialized custom integrated circuits, but for practical purposes, these are servers with a lot of network cards.
Okay.
And they run common software. So you might have a smaller device that's handling maybe only 10 to 20 devices, or a really big device that's talking to the internet at large, but they're still using the same API if they came from the same vendor.
Okay. So in terms of thinking about a machine, that machine may within it have network cards. So you would, in that case, have one provider into that machine that then delegates it to the network cards that then manages other things on the network. Is that correct?
Sort of, the network cards being the resources you're managing on that machine. But the point being here that, let's make this concrete. We'll use the example of Arista. So Arista makes a broad variety of hardware. And they make stuff that you would use in a small office complex all the way up to internet core routing infrastructure.
Okay.
But it all runs the Arista EOS operating system, which all uses the same gRPC API.
Okay.
So
Gotcha.
It doesn't matter which scale of device you're managing. For each one of them, you'll instantiate one instance of the provider.
Okay, I see. I got you. So that makes sense. It's almost like, where am I going to have to come up with a new provider? It's going to
Right.
be almost vendor, right? Almost the specific
Yeah,
vendor, which kind of makes it feel like the cloud all over again to a certain extent, right?
a little bit. Yeah.
Okay, gotcha. So in that case, like if you have 10 machines, 4 of them are from the same vendor, the other 6 are from another, then realistically, if they're all doing the same thing and they're meant to be in the same workspace, let's say, as you said, they're for the same authority level, they're within the same geographic space, you would have 2 providers that are working and managing those different machines, right?
Right. And then this is where, in that case, if you do have mixed vendor landscapes, this is where modules are extremely powerful.
Okay.
Because
Okay.
if you're doing mixed vendor, maybe you're doing it for like supply chain redundancy, or you have an audit requirement or a compliance requirement to not be single vendor.
Yep.
You're still doing the same thing with both devices. Like an access switch is an access switch no matter who made it.
Okay.
And
Yeah.
so
Yeah.
we can abstract over that with the concept of a module, and that's where we can also incorporate, organization-specific logic to say, this is an access switch. It's going to have these characteristics, and it will take this input data structure that we're probably getting from a vars file. But then inside of that module, we make those concrete types. That's where we actually work with these vendor-specific resource types. We handle their data structures.
Okay.
We transpose data if necessary.
Oh, that's pretty cool. Okay, so that is a world then where what you're working to do is abstract the differences away from each of the different vendor specific, interactions, and make it so you can actually do what you're talking about here, the architecture of modeling a network, because now you're just thinking the individual components, not necessarily how to speak to them under the hood. That's sort of that upfront work that you do, get that out of the way so that you can just write these modules that then piece everything together, right?
Right, yeah. So for programmers, the best way to think about this is it's the difference between an abstract class and its concrete implementation. Your module is the abstract class where you've defined the behavior and what the conceptual thing you're trying to capture. Whereas then the provider and its resources, those are the concrete implementation inside the module that's actually going to go make that config real.
Okay. So for Michael then, he looks across the horizon, data center, blinking lights, hot and cold. Some might say fire and ice, but then they might get, copyright infringement. And what he does first, he looks at all of the different machines. He groups the machines more or less by vendor. That's, a little bit of an oversimplification, and thus become a provider is born for each one of those. The providers then are Michael's way to interact with those machines. He then looks at all of them based on who should have access and do things to them, where they are in the geography, and he starts splitting them by Terraform workspace, whether you're CE, HCP, or enterprise, right? He starts splitting those up based on those parameters, right? His next step then is thinking about them. Well, maybe this could come before, is abstracting them by function, right? By creating modules, so that in each one of these different workspaces, now he has the building blocks that let him just think like a network, right? And be able to just put them together. Is this correct?
Mm-hmm. Yeah. A lot of it really is thinking about, if you're standing in front of a whiteboard and somebody says, draw your network, each thing you draw on there is going to be something you'll need to consider in your workspace. And usually it's, I actually find this really helpful to do on a whiteboard. So it's the kind of thing that's great to write it out and don't immediately implement. This is the kind of thing that you want to stew on. Sometimes for, maybe a week. You leave it on your whiteboard, you look at it, you think about it, you think about, does this actually work how I thought it did?
Yeah. And that kind of pulls us into now the question that is a lot easier to deal with if you screw up in the cloud, right?
Yeah.
What happens when you screw up in the physical world? Because there's probably some more implications here, right? If and it doesn't necessarily even have to be your screw up. It could be something happening there, right?
Yeah. Well, I had a manager many years back who was fond of the phrase, and I have to give him credit for it here. When you screw up in the physical world, order food. It takes a lot longer to roll it back when someone may have to get in a truck or a car and go drive out to whatever your oops moment was, back out the change manually. But that's only recovering from it. I think when we talk about setting up the Terraform, it's also important to think about how do we intentionally get ourselves into non-nominal scenarios. And that sounds like a really weird thing to want to do. But we have to remember when we're dealing with the physical network, it's not just our network that can be broken. You could have a provider go out, and so suddenly now you need to sling your traffic around via a different route. You may encounter a DDoS attack, and you need to mitigate that at the network level because it's melting down your application servers. You may even be dealing with something where it's going to be an exciting moment. Uncomfortably exciting infrastructure moments are always fun. Maybe you're hosting some media asset for a pop star, and they're going to drop their new single, so you're about to have a lot of traffic. You want to get ahead of that. So it's also architecting your workspaces and setting up your workflows to handle these non-nominal use cases.
Okay. And what is that? Let's go for a known one. Let's not scare people too much. This is coming.
Yeah.
And you've got everything in your configured in Terraform, right? Thus to where you can control it ideally, right? We'll go to a point where that connection breaks next. But in that case, what does that look like for you in the old world minus Terraform versus now in the new world where you're able to just do that right there in code?
Yeah, so in ye olden times, that would be an engineer sitting there, usually on a conference call. Depending on what kind of thing it is, it may be an actual, old school conference call where you've dialed into a bridge number.
Okay.
And you've got your hand hovering over enter. Command's already typed out. It's ready to go. You just hit enter and it applies. And you're kind of watching the clock to see what's going on. In the Terraform world, this is a variable. You factor out these changes that you might need to make into variables. And so I've even done this before where I have weeks in advance committed in to get a commented out block that is, on this day, at this time, we're going to go into this config mode. It's just check out the branch and apply. Or what I've started to look into how to do, because this is, for me, the next step of this, is with TFC and HCP Terraform, scheduling that apply.
Oh, yeah.
To say, look, this is an event I know is coming. Why do I have to be up at 4 a.m. to make my automation should be able to do that. And that's really kind of where we're starting to get to is, breaking away from the world of humans with hands-on keyboards, making changes in real time to that's what we have automation for.
Yeah. No, I like that. That's what though happens when you do make that run and it fails and for certain, right? Something broke there. How do you even go about diagnosing that, right? Because initially, unless you've got good error logging and everything else, right, it may be a little bit ambiguous. How do you start troubleshooting that there?
Well, it really kind of depends on the scale of the oops moment.
Okay.
In the worst case, you have this Looney Tunes moment where you're standing on the tree branch, sawing the branch you're standing on.
Oh, okay.
And we kind of have that, you hit apply, and I'm sure people have experienced this. You have that sixth sense moment of the apply is running out, the text stops scrolling for a moment, and it's like Wile E. Coyote just off the edge of the cliff. He's not standing on the ground anymore. You kind of have to figure out what's the scale of the breakage. At the best case, a lot of network equipment has a concept of a safe mode or a heartbeat command where you might open a second terminal up to that device if you're making a hazardous change. And if your connection drops, it will roll back automatically to the last known good state. Okay. Because that's kind of the difference here between the cloud and the physical world is in the cloud, you always have an out-of-band channel, something that you can connect even if everything is broken. But when we're talking about the physical network, well, that's the thing that's providing your out-of-band channel.
Yeah.
pretty much everything is in band all the time
Yeah.
from a controls perspective.
Yeah. Yeah. There's no I'm gonna go to the actual cloud console now and fix this because I just screwed up. That's not there.
Right. Now, we do have, for the physical stuff, if we're having a really bad day, there's an engineer at work who showed me these things, and they're pretty cool. It's basically a cell phone that's rack mounted. Like it's a cell modem, it's got all of that on it, and then it has console cables that you go plug in to devices that you don't want to lose access to. So even if the whole network is dead, you still have this one magic device that as long as it's got power, you can get back in. But that's like the bad day. You don't want to have to. You want to test your Terraform. You want to know it works, and you don't want to get into that.
Yeah. So what's funny is we've kind of bridged into that third point, right? Into the third subtopic. So now that you all understand, there's, when stuff goes wrong in this world, it's going to be very different from it going wrong in, say, like, GCP, where you can just hit the console and hopefully roll it back, right? So this is the third point we wanted to touch on, Michael. Like, you already obviously said it in the intro, but just so we have a chapter here for everyone, it is what?
So this is really going to be looking at the responsibility and the risks that are different when you work with physical infrastructure.
Mm-hmm. And that one right there was in-band versus out-of-band communication. You're always in band. If that goes down, you better hope you have that little cell phone device hooked up, ready to go, right?
Yeah, the problem is very quickly your out-of-band communication becomes someone gets in a car and drives there. And the U.S. highway system is a very effective out-of-band communications channel. A little slow.
Oh, man. Yeah. Being in LA, I'm like, is it though?
See, I can't help if your out-of-band system is down too.
Yeah. Yeah. No, that's fair. But that's important to keep in mind. There's for these situations, not necessarily, the bailout's going to be a lot more steps, literally, or in this case, miles, right?
And I think that kind of goes back to, looking at the kinds of changes you make and your architectural considerations. And there are different risk profiles here. If you're making a routine change, you can probably just ship it. Mm-hmm. But if it is one of those changes where, like, let's say you're changing the network topology to account for, some high influx of traffic, like a Black Friday type scenario, you probably want to pre-stage someone at the data center. So that, if something goes wrong, they're just a phone call away. You're not having to have somebody drive in.
Yeah, that's a very good point. Hey, I might mess up. Can you just go be there, just in case?
There's a cafe. I really think you should check it out. It's across the street from the data center.
Yeah. So this kind of the next idea that you had kind of goes back to the Wile E. Coyote moment, right? Of push it, and why is that's so important, right? Like, take us into that second sort of sub point under this topic.
Right. So how we used to do this, and doing this by hand, realistically, the fastest you could possibly make changes to your equipment was as fast as you could type. And I had, I am from the age where when I was taught to type, we had, the big cardboard boxes over the keyboards. You can't look, so you had better touch type fast. Even then, I can still only average about one command into a piece of equipment every 10 to 15 seconds, typing it, looking at it, hitting enter. Mm-hmm. Terraform, on the other hand, can move terrifyingly fast. It can do dozens of commands per second into the equipment, and that is a horse of a different color.
Yeah, because I can imagine here, you're on the floor, you have 10 machines you need to touch, or maybe one machine with just 10 different commands you need to touch. That's like, right? That's going to come serially. You're going to be able to see if something happens. However, if you're like on HTTP Terraform and you've got like, who knows how many different workspaces all set with like a scheduled run, like you mentioned earlier, and it all just starts going, and that touches who knows how many different machines. That all happens, right, very, very quickly. And while that's wonderful, you're saying that's a risk, right?
Right. So to give an example and put some concrete numbers here, let's take, for example, the router that's downstairs. It's actually running my home network, which is probably the complexity of a moderate-sized small company.
Okay.
Not many people's home networks have BGP running in them, I'd imagine. That network is configured with one workspace, 3 providers, and about 2,500 individual resources.
Oh, wow.
An end-to-end apply takes 9 seconds. So we're moving fast.
Yeah.
Now that's, I am physically on that network, so the apply can move extremely fast. If you're talking about an apply running at a remote data center, then you do have time of light delay to send the commands, but it's still fast.
And with that, just to go back to the highway system, not to curse anything here, the faster you go, the worse the accident's going to be, right?
Right. When I was setting that router up, I had a number of incidents where I would run an apply, Terraform would lock up, and then the apply would actually crash out. I would get a context deadline exceeded, and then the red text that everybody hates to see, which is like, hey, your apply crashed, your infrastructure might be in an inconsistent state now. Like, really? And in those cases, I would have to walk downstairs, plug a physical console cable into the device, and figure out what had happened. I very quickly learned that my equipment had a safe mode that I could say, hey, if I don't tell you explicitly to come out of safe mode in 5 minutes, roll back to here. And you kind of get this transactional concept then of like, we open the safe mode, we apply the Terraform, we release the safe mode.
Okay. I mean, that makes sense, right? Especially since, again, the conversation we had previous point, the in-band, out-of-band, right? So that, in terms of it going very fast, right? As a result, that means that those errors can fly at your face much faster. That plays back into the previous takeaway. But of course, we have a situation where that doesn't. None of the bad things happen. You do get it set it up the first time. Someone walks in, they open up your myriad of workspaces spanning across who knows how many devices, how many custom providers you've written for each of them, or ones that you've pulled that have been written for you. How are you what is the next responsibility that you need to have when you're bringing on people into this world of Michael Aldridge?
Yeah, well, this is really the responsibility we always have as infrastructure engineering. And that is, infrastructure engineering exists for the sole purpose to enable developers to build applications to serve some functional use case. So we're really talking about the shift left concept here, where no longer should an engineer need to come to you and ask for a ticket. You're making this self-serve. Once you have it, I like the phrase reduced to practice. Okay. You're not blazing a trail through things anymore. You have it down to, if you want to set this up, you edit this variable file, copy paste the one above it, change the values for what you need, and submit the file to automation. Now you're just acting as an approver. You are a set of human eyes who's looking at the change and saying, yep, LGTM. But when you do that, that's really a responsibility to not only make it available, but to educate. Because you're now expanding what was previously your domain and something you managed and were responsible for, and making it something that somebody who is not a full-time infrastructure engineer, something that they can manage, giving them that flexibility to go, move fast, not break things, and deliver better stuff.
And I mean, this is kind of plays back to one of the things you said earlier, which was this is going to become, while things become easier for you day-to-day operationally, you're doing this because you're abstracting things away. You're abstracting it, but that also makes it easier to lose touch with what's going on under the hood, thus your ability to deal with it if something, very low level goes wrong, right?
Absolutely. It's kind of the, why do I have to know how to do this? My calculator knows how to do it.
Yeah.
Well, yeah, that analogy may not hold up anymore because we're all carrying high-performance computers in our pockets now.
Yep.
But you still need to know why it works. You have to know how to tell the system what you want it to do, and that concept still applies here. Terraform may be able to save you a lot of daytime work in your routine changes, but you still have to focus on your production excellence. You still have to keep your skills sharp, and you still have to make sure that you're teaching the people around you how the system works.
Yeah, and that doesn't seem like a big deal when things are going wonderfully, but it is the biggest thing in the world when things are going terribly. So,
Oh, yes.
yeah.
Yes. You don't want to be at 3 in the morning getting woken up by a pager and going, wait a minute, didn't I need to be on the old version of Terraform for this workspace to run?
Yeah, fair. Well, I think that kind of brings us to those main three things, right? We walked through the sort of baseline, get everyone up to speed with the hardware, what's going on there, how you would connect to it. Then we went into, okay, you've got that up in place. How do we model this? How do we think about this from the Terraform perspective? How do we bridge that? How you would think about the physical network space? And then finally looking at sort of the risks and everything. But if you had to sum all this up, for the audience, what is Michael Aldridge's summary about the topic and sort of the big takeaway that you'd like people to have?
Yeah, so I think the really big, wrap up here is that Terraform is a very powerful tool. And while we often think of it in terms of the cloud and in terms of API-based access, ultimately what Terraform is a very complicated and sophisticated graph engine with an intent management layer on top. We can use that to manage other things. And when we manage more disparate technologies using these same abstractions, we amortize the effort to build those abstractions and we lower the cognitive load on the engineers who have to keep the systems running. And Terraform is a very powerful tool to sit in the center of that and be that abstraction because it's so flexible.
I like that. I do like that because now you have your cloud engineers and your on-prem engineers and your actual data center folks and everyone with the ability to interface the same way, to speak the same language, right?
Mm-hmm.
Nice.
And it reduces the likelihood that something's going to be misinterpreted. You go from saying, I want to make this series of 30 commands next week to here's the TF diff.
Yep, there we go.
It's a lot easier to communicate when everybody speaks the same language.
Yeah, nice. I like that. Well, Michael, I think we had some different resources that you wanted folks to check out. So why don't I begin with the first one here? You can tell us about it.
Yeah, so a lot of the concepts that I've been working on here are, things that we're exploring in my day job, but are a little bit further out than we're comfortable running the large-scale sites on yet. So if you want to see these concepts in reality, I'm in the process of building out a Nomad cluster where everything from the bare metal up is managed with Terraform. And so this is the first post in the series. This is looking at, how do we actually bootstrap that physical hardware? And in this series, I'm going to be exploring a lot of the concepts we talked about today of using these cloud native tools to manage physical infrastructure.
Very nice. Yeah, so check that out. The link's there. If it flashes too fast, again, this is going to be recorded, so you can just come right to about 57:35 here, pause it, and you'll have it. And then, of course, our Michael here is an engineer, and what is an engineer without a GitHub account here?
So this is the source code that backs that blog post series. So if you want to follow along and you want to see, we talked about what are these Terraform resources. They're all there in the Terraform directory. So you can see what does a complete network look like as Terraform.
Nice. All right. So let me take that down here. Again, thank you so much. This was Treat Your Network Hardware Like the Cloud with Terraform. We went through a lot of really, really good things. Did you have any other thoughts you'd like to share, Michael?
Yeah, I think that just, for people who've watched today or maybe are watching this as a replay, the biggest thing I want you to take away from this is to learn the fullest capability of what your tools can do. They may do a lot more than you thought. Learning about the edge of what they can do will give you unique ideas on how to further improve your craft.
Nice. Love it. Absolutely love it. Well, thank you so much, Michael, for taking the time to come on here and share your thoughts, your ideas surrounding this topic. I mean, it's been a very fun conversation, and quite frankly, I got a ton out of it, even from the beginning when we were going through it. Thanks to everyone who's tuned in live that's been watching with us and following along, and thank you to everyone in the future who may come back and watch this. Hopefully you can get something out of it. There's going to be more episodes of the HashiCorp Ambassador Thought Leader series, so until next time, everyone.